know if I like.
All right, y'all ready? All right. What you want to do?
I have a question. Would this be available online somewhere?
Just give me your email when we're done. So you're not in my Blackboard. I
Okay.
can give it to you.
Excellent, thank you.
And do me a favor and pass it on to anybody you can.
Okay.
Well, 1 through 8 is pretty basic, so let's start with number 9.
Anybody want 1 through 8?
Sorry.
Number 8?
Yeah. I didn't even make that assumption.
Yeah, I kind of remember.
I was basically meaning like, well, number 8 is an experiment, but they didn't do anything.
Exactly. So a quality control specialist compares the output from a machine with a new lubricant to the output of the machine with the old lubricant. So is that an experiment or an observational study?
Observational study?
Good question.
Well, actually, it says it's A, but I'm like, what?
Well, there
Because all they did was compare. They didn't like do anything.
they did change lubricants though. So I'm guessing the person who changes lubricants isn't the one who actually has to determine if it's doing a good job or not. So this guy's job was to determine was the original lubricant good or the new one. So it was an experiment between lubricants. But I understand what you're saying. It is a little vague, but because they changed something. It's not like they measured fish from a pond and watched the natural effects happening. So they actually changed the lubricant. That's why it would be considered an experiment. Yes?
Would like an experiment have to do with it, like the different types of machine or oil-based or lubricant being like an independent variable and that presence of an independent variable making it an experiment?
Yeah, we didn't use those words in the definition, but yeah, basically.
Okay.
The observational is more of watching the effects of pollution on a pond. Nobody purposely pollutes a pond. I mean, they are, I guess, but you're watching for the effects of pollution, not actually purposely polluting a pond. Does that make sense, the difference? Here they changed the lubricant. They actually physically made the decision. So something changed would be the best reason I can give you. All right, what was the other one?
Number 9, I was just going to go down the line.
I'm good with going down the line within reason.
Within reason.
Oh, turn that volume down. I love this computer. It's so much fun to play with all the buttons. There it is. Come on. Alright, so number 9, determine the width of each class. Does anybody remember how you determine the width of a class?
Do you like,
Yes.
yeah, when you subtract some,
It'd be like the 1 from 6.
Ah.
And then 1 6.
You choose consecutive, lower, or even the upper limits work. So we need to subtract these. So 1 and 6, if you subtract those, you get 5. But if you do like 20 and 25, no matter which consecutive, whoops, wrong way. I did have that right. No matter which consecutive you use, you will always get the same width. Okay? What else? Which one?
11.
What is up with this computer? It is set up very strangely. All right. So number 11, a nurse measured the blood pressure of each person who visited her clinic. The following is a relative frequency histogram for the system. All right, so on and so forth. What are we being asked? Last sentence. Approximately what percentage of the people aged 25 to 40, which is what this whole table is, whole table is 25 to 40, had a systolic blood pressure between 110 and 139 inclusive? So if we mark on our little table here, here's 110. Where's 139?
In between 130 and
Right before 140. Okay, so more than likely the way they have built this is they built it so that the 110 goes into the box after the number, 120 goes into the box after the number, 140 goes in after the number. So where would 139 be?
130 to 140.
It would be in here. So this is the biggest, the last box we need. Okay, the next box includes 140, or at least starts there. So the best we can do is to take these three boxes, and together, those are all the blood pressures from 110 to 139. Does that make sense? Are there questions about why I chose those? Okay, those are the boxes. Now you've got to figure out what percentage. Now, you're looking for percentage, but all the heights are relative frequency. How do you change a relative frequency to a percentage?
I think you subtract something.
Nope. You move the decimal. You just multiply by 100. That's it. Relative frequencies are the fraction, or the decimal. You're just multiply by 100 to turn it into a percentage. So, we have relative frequencies. We need to find the percentage of people in these three categories, these three classes. How would you do that?
Add them and then divide it by the total.
Add what?
Your three boxes.
What about the boxes are you collecting?
Are you adding the relative frequencies together?
And how do I get the relative frequency for the boxes?
The number contained in each one.
The height of them.
Yes.
So 0.35. That looks about like 0.25. And 0.15. So we add up the three heights for the three boxes in our interval. 3, 4, 5, 6.75, I think. That's the relative frequency. You need the percentage, so you multiply by 100. And whatever's closest, because this is approximate. There you go. Questions? Yes, sir?
Number 13?
Okay. What are you doing? There we go. All right. Listed below are the amounts of weight change in pounds for 12 women during their first year of work after graduating from college. Positive values correspond to women who gained weight, and negative, those who lost weight. What is the mean weight change? So what are they asking you to do?
The average.
Average. So you're trying to find X bar. You add up what?
All of them.
All the data values and
Divided by n, or the number of pounds.
very good. Now, some of these are negative and some of these are positive, so you will be subtracting and adding. You keep the sign that are appropriate. Okay? So we add up all those numbers. So just punch them in your calculator with whatever sign they have. I'm going to need help here.
This one, that's 40.
40 divided by how many? 12. Hey, I have a calculator. I can't operate. It's so simple, though, apparently. Did you get 3.33? Now, rounding, they rounded it to one decimal place, so it would be 3.3. So just be careful. Make sure you add and keep their signs in mind. All right. Oh, what else? Number 17. I like 17. It's an interesting question. Alright, so we're at a tennis championship here, and the statistician keeps track of every serve that a player hits during the tournament. The statistician reported that the mean serve speed of a particular player was 95 miles per hour. Okay, so let's pull that out first. The mean was 95. Suppose that the statistician indicated that the serve speed distribution was skewed to the left. You remember what that means, skewed to the left? What would it look like?
The opposite of what you would think.
Want me to draw a picture? I just drew it in the air.
So it's kind of like a bell shape.
Yeah, but it's leaning to the left.
It's got a tail to the left.
Yes.
Okay? The tail is where the skewedness is. Now, our mean is 95. So our mean is somewhere on here, 95. Does anybody remember when you're left skewed, which of the following values is most likely the value of the median? So if this is your mean, does anybody remember, if it's left skewed, where would your median be in relation to the mean? To the right. Anybody remember why? It's the middle number. Both of these are technically middles, but the mean is affected by extreme values. You have an extreme value pulling the mean more to the left. The median is not affected by extremes. Now, what do you now know the median has to be?
More than 95.
More than 95. So that's how you find your answer, and therefore it has to be 102. It's the only one that's bigger than your mean. What if it was bell-shaped? Where would the median be? What if it's symmetric?
95.
It would be at the mean. Very good. Mean and median are the same if it's bell-shaped. Right skewed?
That's
Your median would be less. All right, make sure y'all remember, your final exam review is a basics. Just because I ask you one question doesn't mean you could be asked the complete opposite on the test. All right, what else? Yeah, 19? All right. All right, where's the actual question?
Under 18.
Right here. Thank you. All right, the mean of the test scores is 74. So the mean is 74. Additional information indicated that the median was 84. What type of distribution most likely describes the shape of the test scores? Choices are skewed left, skewed right, symmetric, or we don't have enough information.
Would it be skewed to the left?
Why?
Because the mean would be, if you have your mean, which is affected by extreme values, but the median is farther to the right than the mean. So if you have your mean skewed to the left a little bit.
Very good. So this is skewed left because the mean is being pulled to smaller values. So that means there's extreme value to the left. So this is skewed to the left. Questions?
Reading number 24.
Okay. All right, the directions up above say find the range. Is that still applying? Yeah, find the range. So how do you calculate a range? Now this is a little tricky because you got negative signs in here.
What you do the biggest number from the smallest?
Maximum minus the minimum. So what's the biggest value? Hint, it's positive. 81 is the biggest. And the smallest is a negative value. Now be careful How should I plug this in?
I would become a positive.
You have a negative sign in the formula, and then you're plugging in a negative number to the formula. So you actually end up adding the two together. Okay? What else? Okay, what were the directions? Oh, let me copy the directions over. All right, lucky for us, it actually tells us to use the empirical rule. Now, on your test, make sure you use the empirical rule when appropriate, because you now have the z-scores, which are actually better at giving you area and percentages. So only use the empirical rule when you're told to. Otherwise, you're going to be using z-scores to find percentages on a bell curve. All right, suppose that prices of a certain model of new homes are normally distributed. What should you do as soon as you see this word? Draw yourself a bell curve. This is multiple choice. Multiple choice does not require you to show work on the test, but it helps you figure out what you're doing. What do you know about a mean on a bell curve? So in the middle, I'm put this number. All right, the mean. Use the empirical rule to find the percentage of buyers who paid between $150,000, that's our mean, so we're interested in this number here, and $152,200. So that's to the right. Let's mark that number. $152,200. So what are we looking for in the bell curve?
The area between the mean and the indicated value.
Very good. This area is our percentage that we want. Now, you're using the empirical rule. Does anybody remember the empirical rule?
What's the number? I bet, 0.50 and then 2.35 and
Oh, you've got all of them memorized?
34.
It's cheating.
I looked at it yesterday.
What are the three that it's all based off of?
I like the different standards.
Like, isn't there one like 60 something?
68. And? There we go. Now, this is for 1 standard deviation, 2 standard deviations, and 3 standard deviations from the mean. Can I use that notation now? Are y'all familiar enough with sigma? Yay! Shorthand. Okay. How many standard deviations have we gone from the mean here? Careful. Standard deviation is 1,100. So they've added 2,200. That's 2 standard deviations. That was loud. Okay. So does that mean, because we're 2 standard deviations from the mean, that we automatically go to 95 and that's our answer? No. The 95 is where in the bell curve?
Some with the left and the right side.
2 standard deviations to the left and the right. So how do I get just 2 standard deviations to the right?
Add.
No. Nope.
Would you divide them in half?
Why can you divide it in half?
Because both sides are like of equal size.
Perfect.
So,
You're right. That's called symmetry. Bell curves are symmetric. So when you have my picture, you know that both of these areas together are 95%. Because it's symmetric around the mean, you just divide by 2. So our answer is going to be the 95 divided by 2. So that would be 47.5%. Questions? Yeah.
If we were using the Z table, we would just do the same thing and divide by 2, right?
The Z table gives you the area all the way to the left. So the Z table would have given you all of this here. But then you would just subtract off 0.5, half of a bell curve, to get your area. But the z-table will give you a different percentage because it's actually more specific. More questions?
Can you do 29 or 30?
Okay. All right, how do you convert a data item to a z-score?
Sum alpha over 2 times something, something, something.
Isn't it the X bar minus the mu divided by the standard deviation?
You're on the right track, but we're just doing a data value, not a mean. So it's just the x minus mu divided by sigma. Remember, you should, actually right now, you should have a piece of paper out called your cheat sheet, and you should be writing on your cheat sheet anything that's not familiar to you. That's what you should be doing as you go through your review, saying, oh, I don't remember that, I better write that down. So, start working on that. Everybody knows, one side of a regular sheet of paper, anything you want on it. No formula sheets are given to you on your final. You have to bring your own. All right, so what is our data value that we're converting here?
What was the question?
What data value are we trying to convert?
Normally distributed one.
Normally distributed allows us to use a z-score. The 92. Where's the 92 go in the formula? That's your x minus the mu, which is your mean. Does it give us a mean? It did in the dark letters. Your dark letters are important on these exams. Sometimes they tell you it's normal in the dark letters. Sometimes they give you important information like the mean in the dark letters. Sometimes they tell you to use the empirical rule. Read the dark letters. They're not there for fluff. They also gave you a standard deviation of 8. And we plug it all in. So that's 4. Well, in this question, it just asked you for the z-score. So this is the first step in using a z-score table is create the z-score. What else? Okay, I think this is backwards. All right, this one, they give you the z-score and ask you to find, where does it say it? Find the data item. So who are they asking you to find? What's the x? The symbol would be x for the data. So they're giving you z. How do you find x? You're right. It's this formula where they've solved for x. So what they do is they multiply the sigma over to the other side. Then they add the mean to the other side to get their x. This is a formula you should have on your cheat sheet. Why not? You got a whole sheet of paper. If you need a magnifying glass to read it, bring your own. I do not provide magnifying glasses. I just laugh at how awesome y'all are at squeezing tons of information. Some of you are going to start writing so small and only fill up half a sheet of paper and look at it like, really? That happens. But hey, that means you learned a lot. All right, so we plug everything in here. Z. Okay, they gave us that. That's 2. What's sigma? Your standard deviation is 10. Plus our mean is somewhere. The mean is given to you, 500. All right, so we have x equals 20 plus 500, which is, and there you go. Whoops, wrong button.
What number is that?
31. Yeah.
If when we're going through this in order, you find one that you know people get wrong a lot, could you just kind of go over that with us?
So far, y'all are hitting pretty much everything, but yeah. All right, what else? Make sure we didn't miss anything. 33.
Actually, maybe to save y'all some time, that was actually on the thing paper that you included.
Formula sheet? Or the solutions I worked out?
Yeah.
A lot of them are. But I know it's a lot easier to understand if you actually see it worked out. That's why I'm here. Otherwise, I would just write them all up, post them on Blackboard, and say good luck. Actually, I'm recording this so I can use it this summer, and I don't have to do this summer. See, I have some intelligence. All right, how do you find the percentile of a particular data value? No?
How many times does it repeat?
No? That would be finding the mode. Which one's the mode?
I don't know, does it have to do with, if you count all the way down, number 2 is the 14th value.
No?
No?
So they want the percentile of this value, the number 14. Very good. It's the number of values less than 14. And then what do you do with that? Divide by the total number of values. So how many values are less than 14 here? All right.
Eight numbers.
I got 9.
I'm good at not seeing stuff that's there, so.
This is a common one that is made. I see a lot of mistakes on this in tests, is miscounting how many. So that's not a common. That is a common issue. Always double check your work.
I got 15.
Yeah, what happened to you?
Well, see, I can't even count right. Oh, I forgot to count the 14. That's why. All right. Calculator, what is that? We want a percentile, so we got to change this to a percentage. So first you divide and get the decimal. How do you turn a decimal into a percentage? Move the decimal 2 places, exactly. All right. What else? Okay. Anybody remember what Q3 means?
Something like quadrant.
Close. Quartile.
Quartile.
It says third quartile.
It's like a box and you split it into parts.
Mm-hmm.
Maybe.
It's what? Did you say 25 or 75? 75%. So this is the 75th percentile. This means that 75% of the values are less than the number you're looking for, your P75. So P75 is representing one data value such that 75% of the others are less than that value. So we got to find that out. Now, I will give you a huge, huge point here. Look at these numbers. What's wrong with these numbers here?
They are less than 75.
75%.
Than 75%.
So of these data values, you have 100% of data values here. 3/4 of these, 75% of these data values are going to be less than the number you're looking for.
There's multiple of the same one.
There's a bunch of 52s.
Okay, y'all are noticing something that's interesting about the data, I agree. But there's something wrong with how this is set up if you're looking for a percentile. For percentiles and quartiles, you need your data values in order. So let me do that. 49, 52, 52, 52, 55, 55, 67, 74. Did I get them all? I think I got them all. All right. So, how do you find a data value for a particular percentile? Anybody remember?
I still think you like draw like a box.
You could.
I don't know. I can't. That's the only thing that's sticking out.
In this question, you actually could because there's a very nice number of values. For example, if I draw a line right here, how much is to the left of my line? 50%. How much is to the right? 50%. Now, if I draw halfway in between each of those, these represent our quartiles. There's 25% in each box. Good? Does anybody know which of the answers is the answer? Okay, see, that's the issue. We have two possibilities, don't we? If you look at the answer choices, there's two different values that could be the answer. You agree? 61 and 67 both have 75% of the data values less than it. So this is where you have to go back to the book and say, how does the book define the data value? And to do that, we do what's called the locator. K divided by 100 times N. So what is our K? Anybody remember? The 75 divided by 100 times what's N? 8. So this is actually 6. Now, the locator is one of those funky things that has some funky rules to go with it. Anybody remember what those rules are? Again, this is a cheat sheet note that you should make. If L is a decimal, does anybody remember what to do? You round up. If L is a whole number, you take that number, that data value I should say. So in this case we have a 6, that's a whole number. We take that data value and the next data value. And do what with those?
Find the mean or something.
Yep, average them or find the mean, either way, same thing. So these are the rules no matter what your L is. Now for our case, we have a whole number, so we're going to take the 6th data value and the 7th data value in order. All right, so here's 6 and 7. Those are the data values we need. We add them together and divide by 2. And I'm guessing we get 61. This way?
So the online people are going to see like the ones you're doing at the same time.
Whatever you see up there is what they will see.
That's so cool.
Unless I messed up.
And then you use that same formula for the next one.
What was this one? 35. For 36, yes, you use the same formula, but you don't have a Q. You just go straight to your P, and your K value will be the 46. Do we want to do 36? So again, you're trying to find the data value, so you use your locator. K divided by 100 times N. So our K is 46 divided by 100. What is our N? 32, the number of students, if that's the number of students that are there, which it should be. All right, what number is that? Calculators. All right. When your locator is a decimal, what do you do? So we're going to round this up to, what was a 14.01? No matter how small the decimal is, you always round locators up. So we need the 15th data value. 15 is not your answer. Look, it's there to trick you. Your answer is the data value that is in the 15th position. Aren't you glad for 32 data values we are nice and put them in order?
Yes.
All right, 5 and 15. 16. There you go. Notice they did put the option there that if you had done 14 and 15, you would have an answer. So there are things here to trick you. Make sure you're very careful about using your cheat sheet to remember the rules. All right, what else?
We do 40 and
40. Ooh, excuse me. All right, you're rolling 2 6-sided dice, and you're asked to find the probability that the sum of the dice will be 4. Now, you could write down your sample space, meaning every possible outcome. But does anybody remember when you roll 2 dice, how many outcomes are possible?
36.
Very good. It's 6 for the first die, 6 ways for the second die, and if you remember the tree diagram, when you have 2 independent events, you multiply each together to get the total number of possibilities. Now, how many of those can you get a sum of 4 in? Now here is where I suggest you write it down. And be careful, I saw a lot of mistakes on the test in how many ways you can get 4. So you're rolling a 6-sided die and a 6-sided die. What numbers add up to be 4?
2 and 2. 1 and 3.
I saw a lot of people put 2 and 2 again. Does that make sense?
Yeah, I did that.
Does that make sense? If you have a 2 and a 2, is there any other way to get 2 and 2? No, this die has a 2, this die has a 2, they're both 2. That's the only way to get 2 and 2. So that doesn't make sense to do it again. It can't happen. Once you have 2 and 2, that's the only way it can happen. So there are 3 ways to get a sum of 4. So what's the probability of getting a sum of 4?
3 out of 36.
3 out of 36. The number of ways it can happen divided by the total number of possible outcomes. Is that the answer? Reduce, and there you go. Questions?
Can I have you to retake this class? I'm just.
Hopefully you don't have to retake the class. Hopefully you will successfully pass the final with flying colors because you're spending adequate time studying. What else? Oh, was there another one there? Oh, 41 was the other one asked. Okay. All right, you toss a coin 5 times. When you toss a coin, how many possible outcomes are there? 1 coin has 2 possible outcomes. If you toss 5 coins, how many outcomes are there?
10.
10.
2 times 2.
10.
2 times 5. 2 times 2 times 2. Oh, 2 to the 5th power.
He had it right. It was 32. Think about it like this. Every coin is independent, kind of like every die was independent. So you have 2 possible outcomes for every single coin, and you multiply those 2's together. So that would be 2 to the 5th, or 32. Hey, you know what? You could cheat. Look at all the denominators. We didn't really cover in depth the idea of counting. We just surface kind of glossed over it. So we try not to test you on that aspect. But that is how you do it. Now, what is the probability of getting heads on the first toss and tails on the next 4 tosses?
Well, each is independent, and you have a 1/2, chance of them getting each one. So don't you times each, half, 5 times?
Okay, there are 2 ways to do this, and that is good, but you've already done most of the work. You've already found the 32. That's the hard part. That's your denominator. I'll do it your way in just a second. Let me finish using what we already have. Now, heads, tails, 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 tails. That exact outcome. How many ways can that exact outcome occur? One way. There you go. Or his idea is to use what I'm very proud that you're using. Use the word and. You want a heads and tails, and tails, and tails, and tails. Independent events, you just multiply their individual probabilities together.
I think that's what we did.
There are 2 different ways to approach the problem, depending on which section we were in, how I showed you to do it. So each of these has a 1/2 probability, and because they're independent, you just multiply them all together, and you still get 1/32. 2 different ways to look at the same problem. It's up to you which way you do it. Especially since it's multiple choice, you can even just guess. Make sure you have an answer for every multiple choice question, please. This is not at the SAT where if you guess, you get minus points. No, you guess in hopes of getting something. All right, what else?
We do 43.
43. So you have a table here of probabilities of having different numbers of girls. So keep in mind, these are kind of separate here. Oh, come on. So we have 0 through 4, then we have 5 through 9, then we have 10 through 14 girls. So this is the probability of having, different color. Probability of having 0 girls, probability of having 1 girl, probability of having 7 girls, probability of having 13 girls. You're interested in the probability of 8. So you just need to go find 8, and that's the probability you want.
I think they just kind of figured off how the chart is.
The chart's a little funky. What if I asked you the probability of 7 or more girls? You would take 7 and everything bigger than that. Add up all those probabilities. Okay? So if you want multiple, you just add them together. Because these are mutually exclusive events. They cannot occur at the same time. Questions?
Can you do 45?
Ooh, determine if it is unusual. And it tells you what unusual means. Consider unusual any result that differs from the mean by more than 2 standard deviations. So if we find mu plus 2 sigma and mu minus 2 sigma, this would be our maximum usual, and this would be our minimum usual. So what we need to do is read this problem, find the mean and the standard deviation, and then the number we're trying to determine whether usual or not. So a survey for brand recognition is done, and it is determined that 68% of consumers have heard of Dole Computer Company. A survey of 800 randomly selected customers is to be conducted. For such groups of 800, would it be unusual, here's what you're trying to figure out, would it be unusual to get 530 customers who recognize the Dole Computer Company brand?
What would you calculate? 68% of 800? What do you do this for?
Hold on.
When you plug those numbers in your little formulas, did it.
It's 68% of 800, right?
That's not using what they said to use, though. There's no mean and standard deviation. What the heck?
We get the percentage of 800 and then find out what the standard deviation is. See if 530 is 2 away from what it would be if it was 800. If the group was 800.
68%. Oh, they're using Chevy Chev.
You gave the formula, you have to find the mean and the standard deviation. You gave the formula on the.
But we can't find mean and... Oh, I know. All right. The mean is n times p, because this is a binomial question. Sorry, I had to think about that one. This is binomial in nature. So the mean, is this the formula I wrote down that you're saying? Okay. The mean is n, which is the number of trials. So we tried 800 people was our survey. Our p, the percentage who recognizes the 68. What was that value? 544? Okay, and then for binomial formula, your sigma is the square root of n times p times q. So 800 times 0.68 times 0.32. What's that value? Good question, sorry. Q is 1 minus p. So 1 minus 0.68, if I did it right, is 0.32. That's your Q.
So answer is 13.193938.
Okay. So now we take our mu, 544, we add 2 times 13, and we take 544 and subtract 2 times 13. Add 26, that'd be 570. Subtract 26, and we get 518. So our value of 530 is where in comparison?
In between.
And because it's in between, is that usual or unusual? Usual. In between is usual. Outside of that would be considered unusual. So, to answer the question, for such groups, would it be unusual? No. Okay. That was fun. See, even I have to think sometimes. The mean and the sigma aren't there. How do you find them?
46.
46. Okay, a mountain search and rescue team received a mean of 0.78 calls per day. Find the probability that on a randomly selected day they will receive fewer than 2 calls.
I remember something. So you have to do the probability of not getting any calls or something.
Probability of 0 calls,
Yes.
1, and that's it. Fewer than 2 would be 0 or 1. What word did I say between those? Or you can have 0 calls, or you can have 1. You can't have 0 and 1 calls on the same day. You either have 0 calls or you have 1 call. How do you do an or probability?
Then to subtract, divide, add.
Okay, eventually you'll get there. Yes, add.
Multiply.
Add was right. These are mutually exclusive events. They cannot happen at the same time. So because they're mutually exclusive, that's why you can add them together. But what have we not actually found?
Value of P0 and P1.
The probability. Yeah, that'd be kind of helpful. And you can't get partial credit here. It's multiple choice. So you better know what you're doing.
Why do we use the binomial table?
Why do you think binomial? a good question, but what do you have to look for to have a binomial?
But I can't figure out this thing.
Well, that's true. They have to be mutually exclusive. Or, no, they have to be independent, not mutually exclusive.
The mean is there.
The mean is the... Oh, what do you know about probabilities when you have a mean? Could it be binomial?
I don't think so, because you can have more than 2 different kinds of outcomes, can't you? You can have 0 calls, 1 call, 2 calls, 1 calls.
Well, you could have infinitely many calls. There's no limit to how many calls you have in a day. That's why it's not binomial. Binomial says you have n phone calls and either they call or not. Does that make sense?
Can you look up on the Z table?
We don't have normal, so we can't use that. That was a good try too. Who are y'all missing that was right after binomial? Poisson. There we go. Not poison. Poisson. Poisson says there's no upper limit, and it uses a mean to calculate probability. This is a Poisson question. These are these are rare chance events. A mountain search and rescue team. Does that sound like a random or a rare event to have a phone call? Do they have phone calls after phone calls after phone calls? No, they're not 911. They're a mountain search and rescue team. Most people who go on the mountain know what they're doing, I hope. Okay, so this is a rare event with no upper limit. So that's why it's Poisson. Now, how do we do Poisson? Again, where should you put this formula? Very good. Mu to the x, e to the negative mu over x factorial. By the way, if anybody has an A in this class and wants to tutor next semester, let me know.
Where do you get your tutor?
Money. All right. What do we plug into this formula? What is mu? 0.78 to the x power e. Oh, yes, I am. You're right. So here's the P0 plus, we'll have to do P1 as well, e to the negative 0.78 over x factorial. So my x value, I'm sorry, I skipped a step. I forgot to mention, x is the value in the parentheses of the p. The other one is 0.78 to the other x. The x is 1 in the second probability. E to the negative 0.78 divided by x factorial. Before you punch this in your calculator, do a little bit of simplifying, okay? If you have 0.78 to the 0 power, what does that equal? 1. Does it do anything? No, it's just multiplying by 1. It doesn't do anything. That's gone. What is 0 factorial by definition?
Itself.
It's 1. If it were 0, it'd be undefined, so that doesn't work. What about 1 factorial by definition? 1. So we can simplify this for calculator purposes to e to the negative 0.78 plus 0.78, the 1 power doesn't do anything, times e to the negative 0.78. So that's what you need to punch in your calculator. And my calculator does not have e here, so I need help.
How many do you want rounded to?
Probability should always be 3 significant figures, unless it's multiple choice. In this case, it's 4.
If that's the case, I got 0.458.
Uh-oh.
But I will not say.
I got 0.81596, but that's
It's up there.
okay.
Do we have a consensus on that answer? Yes.
Let's go with that.
Let me check to make sure that doesn't. I got the thing.
Okay. Questions?
Oh, I didn't add them yet. I was just doing one.
Oh, well, see, you were right. They were ahead of you.
I'm always one step behind.
No, they're one step ahead.
So that means I'm one step behind.
Somebody better be on stride. Okay, what else?
Let's do 47.
Yeah, because that means like,
Do you have to multiply by 3 because it's 3 years?
No. All right. On one tropical island, hurricanes occur with a mean of 2.74 per year. Find the probability that during the next 3 years. Okay, what did you mean multiply by 3? Who are you going to multiply by 3? Okay, yes.
365.
Oh, so that was right?
Yes.
365.
Well, everything is in terms of years, not days. So the mean per year is equal to 2.74. But they are interested in the probability in the next 3 years. So that means we need a mean per 3 years. So 3 times 2.74.
8.2.
Thank you. You said 8.2. 2 twos? Okay. Now, we need the probability that the number of hurricanes will be 2 hurricanes in the next 3 years. Is this okay? Any questions about why we've multiplied by 3? What kind of probability are we going to calculate here? This is Poisson. Remember, Poisson has a interval. In this case, it's a time period. Whatever time period they ask you to do in the probability, that's the time period your mean has to be associated to. So the time period in our probability is 3 years, so our mean has to be for 3 years. Okay? So, in these 3 years, our Poisson probability is going to be, let me write down the formula again, mu to the x, e to the negative mu over x factorial. So our mu we found is 8.22, x is 2, e to the negative 8.22 over 2 factorial. There's really only one thing you can simplify here. Anybody have suggestions on that?
2 factorial.
What is 2 factorial?
2.
2.
I got .009095.
Whoa, you said that way too fast. Oh, wait. So E? What else? 48? You aren't letting me skip anymore, are you?
Because it's 52 and like 54 through 58.
I'm just teasing, it's okay.
Does that just mean the area between 0 and 2.25?
Yes, find the area between 0 and 2.25 is the probability. Now, I've already started, but what should you do first here?
Look up on your table.
Don't look up yet. What should you do first? Draw a bell curve. Why do we draw a bell curve here? And not just any normal, it's standard normal. So who's in the middle of this bell curve? And what's the mean for standard normal?
0 is in the middle.
0. And that's why it's important to recognize that you're interested in the middle. Up to 2.25. So 2.25 is where?
On the right side.
And if you hadn't put the mean on there, you would not know where the 2.25 was. So you need to put the mean first so you know where you're going after that. What are we interested in the picture?
The area between them.
Area between. That's what we're looking for. How do you do that?
This is what we use for so you can refresh your
I heard somebody say something about a z-score.
memory.
On the table. Normal. There it is. Normal table. Z-table. Too small. Alright, so which one are we going to look up on the table?
0 and
Well, 0 you already know. 0 is exactly halfway, so what's half of a bell curve's area?
Between
0.5. The whole bell curve is 1, so half of a bell curve is 0.5 area. So this area here is 0.5. Is that what you're looking for? No. So let's look up 2.25 and see what we get. Alright, so here's 2.2. We go across to under 5. 0.9878 is what I got. Now, where is this 0.9878 in the picture?
Everything to the left.
From the left, everything to the left of 2.25 is correct. Is that what we were looking for? So we're going to take our big 0.9878, we're going to subtract off what we don't want, the red area. What will be left? Which is what we're looking for. That's the green area. Questions? What else? You say 1, 5 or 5, 0?
50.
5, 0? Okay, sorry, they sound the same. 50.
You need that Dixie chart for it.
Need what?
It says use the following uniform Dixie charts for both of us.
Oh, okay, hold on.
Because I think that's what you need.
Hold on. Yes, same chart. Alright, so this is a uniform density. Uniform meaning what? Uniform means that the shape is going to be a rectangle. Okay, so this is a rectangle. That's how you know it's uniform. And we're interested in 4.1. Excuse me. 7.4. So what are we looking for? Those are the numbers, but what are you trying to find? The area in between. Now, to find area of this shape, what shape are we finding area of? Area of a rectangle. How do you find the area of a rectangle? Alright? Now, the whole rectangle is not what we're interested in. We're interested in just the red area. Thankfully, they've given you the height already. But just in case, does anybody remember how to find this height?
length divided by 1.
The other way around, but yes, you're right. 1 divided by the base or the length, either way you want to call it. So whatever the base is, 1 over that would be the height, just in case your problem doesn't have that. But we right now are interested in the red area. So length times width of the red area is what? What's the height of the red area? 0.125. What's the base or width? Subtract. The big one minus the small one will give you the base. So 0.125 times 3.3. Did y'all get 0.4125? Okay. There are snacks in the lobby if y'all want any. They're free. College Learning Center, learning whatever, brought stuff. So if you need sugar, it's out there. What else? 59. Let me close this. Really? You're going to let me skip all those?
No.
No.
All right, well, I'm going to do 59. If y'all want me to go back, I can. Again, the dark words are very important. Why are the dark words important in this problem? What information? What? How are they important in this problem, though?
Normal distribution.
Normal. What should you do when you see normal? Draw me the picture. It's multiple choice. You don't have to draw the picture, but you might as well give yourself something to work with.
Am I gonna have more room to draw my picture?
You will not be allowed to write on your multiple choice test, but we will give you scrap paper. We don't want to kill too many trees. Sorry. All right. What do you know about this normal distribution according to the problem? The mean. Where is the mean? In the middle. So 60. Find the probability that x is less than 53. Now, this is the problem I was trying to tell you. It does not say to use empirical rule. Empirical rule can get you an approximate percentage, but because this is normal, we can get closer using z-scores. Z-scores is more specific. So we're going to use the z-score here instead of using empirical rule, because it doesn't tell you to use empirical. All right, so how do we find the probability that x is less than 53? Okay. Before I convert it, though, I'm going to go and put it on the bell curve so I know where it is in relation to the mean. Where is it on my bell curve? To the left of the mean, because it's smaller. And I'm going to make a note. These are my x values. I have to convert those to z-scores. What will the 60 become when we convert it to a z-score? 0. Very good. The mean of z-scores is 0. So the mean is still the mean, and the mean of z is 0. Now, how do we convert 53 to a z-score? Which one?
So alpha over 2.
No.
It's the x minus the u over the c.
Why not x bar? Now I'm going to make you question earlier, aren't I?
Doesn't that give me the... Isn't x bar the same?
X bar is the mean. And they did not say x bar anywhere in this question. Just be careful. X bar is when you have the central limit theorem, when they're asking you a probability of a mean. In this case, they're asking you a probability about an x. But always remember, there are questions where you're asked the probability of a mean and questions where you're asked the probability of x. Two different z formulas. All right, what x are we trying to transform here? 53 minus divided by. So we have -7 divided by 4, or -1.75. I think I got that right.
No, find on the table.
Find what on the table?
Negative 1%.
All right, so I just closed my z-score table. Shouldn't have done that. All right, so zoom out here. -1.75. Too far. .75. Find where they meet. Oh, you're right. I am on positive. I can still get it. It's just more work. Come on. There. What is it doing? It's being weird. What is it doing?
It's 0.040.
There. 1.75, and you said that number there. Okay. Now, where is this in our bell curve? Table always gives you area to the left. Now, what were we looking for?
Area to the right.
Less than, which is which way? To the left. So our area is our answer. There's a little fan back here. I'm trying to discover why it's back here. Got like 600 computer things going on. It's hot. But there's no outlet. Go figure. Oh well, find it later. All right, what else?
Everything. Let me go back to 51.
51?
Yes.
All right, 51. What's the very important keyword here to know anything at all that you're supposed to do?
Uniform distribution.
Uniform means what?
Rectangle.
Do what?
Rectangle.
Rectangle. Okay. All right, so we draw a rectangle. Use my little shape machine. Now, luckily I reminded you already. Did you write it down? You've got to find the dimensions of this rectangle. Where do we start?
6 on this side, 12 on that side.
6 and 12 are the limits on the bottom, the range of values that we're interested in our distribution. Now, how do you find the last dimension? Minus what?
11.
11 minus 6.
No?
Would you do 1 divided by 12 minus 6, which is the base?
Very good. The height is 1 over the base, and the base here, just subtract. 12 minus 6 is 6, so our height is 1 over 6.
Can we just do that as a fraction?
Can we what?
Can we just leave that as a fraction?
Look at your answer choices. Your answer choices are all in fractions, so you probably want to leave it as a fraction. Now, that's your base, or your height, sorry. You have your height, you have your base. You're interested in less than 11 pounds. So what should you mark on your rectangle? Where 11 is, so that's closer to 12. Let's mark it near 12. And you want less than 11 pounds. So which section are you wanting? The left. Very good. And the probability is equal to what about that left-hand side? Probability is the same as what? Area. So how do we find this area here? Length times width. I think I just heard that. Or else I'm hearing what I want to hear. Same thing as base times height, if you prefer that. Either way. I think I heard
6 times 5.
the base of our section is 5. 11 minus 6 is 5. And then the height is the 1/6 still that we already found. So if you multiply fractions, you know how to multiply fractions together? It's 5 over 1. You multiply straight across. So 5 times 1 and 1 times 6, and there you go.
Just a general question, like about 53 to 58. I can assume that the probability that z is less than 113, like that, the like notation that they have, like they have 2 different types of notation, like they basically just mean like the same thing.
Yeah, one's in words and one's in symbols. They mean the same. 55. Now, notice in the dark letters, there's something very important you have to have. What's important in the dark letters?
Standard.
Standard normal. All right. What does normal mean? Very good. Normal means bell curve. Standard means the middle is 0. And we're interested in negative, so to the left, 1.82. But we want z that is greater than, the probability that z is greater than negative 1.82.
So should to the right of that.
Very good. We want to the right. How do we find that?
Can't you look at the positive 1.2 or you can do one?
Yes, you can. That won't confuse anybody. So what do?
Correct?
Subtract what though?
These scores?
Go to your table. Here's negative 1.8. It was 1.82, right?
Yes.
There's your area. But this area is where in our bell curve? To the left. So 0.0344 is this area to the left. Is that what we wanted? How do you get the area that you do want? 1 minus that area. Now, as was already mentioned, you could look up the positive and you'll get the right area because of symmetry, but only do that if you're very confident in going backwards and doing things creatively. Otherwise, look up the value, get the left area, and subtract from 1 to get the right area. Questions? All right, what else?
Should be 62.
62. All right. Use the given data to find the minimum sample size. You're trying to find the minimum sample size. What does that mean? What symbol are you looking for? What? N. Very good. How do you find N when you're involving P and Q? Formula. So formula sheet here, people. We have P hat and Q hat are unknown.
With Z, A, divided by 2, in parentheses squared, times 0.25 over E squared.
Alright, so because P hat and Q hat are unknown, we use 0.25. Not squared, just 0.25. If we had P hat and Q hat, then we would put them there instead and multiply them. Alright, let's start with, well, where do you want to start?
Z. Z alpha divided by 2.
Alright, if this is your confidence level, yes sir.
I just want a reminder. Okay, never mind. It's on.
If your confidence level is 94%, who can you get from that?
Your alpha.
What's alpha?
0.6.
0.06.
0.6.
6%, the remaining 6% is your alpha. Now we want alpha divided by 2, so 0.03. How do we use that to get our z alpha divided by 2?
Look that up in your Z table.
Look up 0.03 where on your z table? In the middle. All right. Now if you look 0.03 up on your table, you're going to be on the negative side. But the notation z alpha, you always give a positive answer. So even if you look it up on the negative side, that's okay. You're just going to change it to a positive for z alpha. So I got negative 1.88 is the closest I could get to 0.03. Are we good with that? Any questions? Going backwards here. Alright, so our z alpha divided by 2 is 1.88, the positive. Now if you put the negative, it's not a huge deal here because you end up squaring it anyway. When you square a negative, it becomes positive. But traditionally, z alpha, the notation, is always a positive. What's your error? 0.04. In this question, they called it margin of error. Sometimes they say within a certain amount. To within is also a common way of describing error. At this point, calculator. Very big hint here. It's not one of our choices. What do? You always round in up because you can't, this is how many you're supposed to sample. You can't sample a quarter of like a human being. That's illegal. Okay? So instead, you always round up. You always want to sample too many. You want to be more information rather than less. Yes, sir.
What's the difference between like that E and the E as a like the number of pieces?
Summation versus error.
Is that what you mean?
Yeah, so it's like E the margin of error.
Yeah.
Okay, I'm asking. Okay.
There's different words they can call the error. Margin of error is one. I just didn't get into the details of the different versions of error.
Okay, that is so confusing. Could you please not use E again? Like use another letter. Like that confusing.
Well, the formula on your formula sheet has E. That's why I use it. But it says error. That's how you know it's your E.
Okay.
Were you? Yeah. Error, a common way of describing error is, there's another one, not just within. I don't remember what it is, though. Yes, sir. 58. Ready? All right, 58. All right, so again, we have standard normal in the dark letters. Don't forget. Where did my, there. All right. So let's draw a bell curve. What do we know because this is standard normal? Who's the mean? All right, we're interested in 0.73 negative, so that's to the left, and to the right. Now, notice it's a lot bigger to the right, so I'm going to make it visually. We go a lot further to the right. We go all the way to 2.27. Now, I don't expect you to draw it to scale, but if you draw it to scale, it can make more sense to you. Just be careful. All right, what are we looking for in this bell curve? Yes, this area in between. How do you find it? Those are z-scores.
Look on negative 0.73 and 2.27.
Look them up in the z-table. All right, so negative 0.73. It's not there. 0, 1, 2. I can't read it. Computer's messing up here. Somebody have it? Is it 0.2327? Computer's making that number fuzzy. All right, I got 0.2327, I think. I'm having trouble reading that there. What did I say? Alright. That's the area to the left of the value we just looked up. So now we look up 2.27 on the positive side of our z-score table. Of course, it's not going to fit on my screen. Zoom out. There.
0.9884.
Okay, cool. Now 0.9884 though is all of this area to the left of that z-score.
So you subtract 0.2327 and you have your answer.
Good. So you take the big area minus the blue, because you did not shade the blue. That's not what you want. You subtract it off, and what's left behind will be what you wanted. Questions? What else?
66.
66. Use the given information to find the minimum sample size required to estimate an unknown population mean mu. What are we trying to find? N. Okay. How many women must be randomly selected to estimate the mean weight of women in one age group? We want 90% confidence that the sample mean is within. So here's that within word, by the way. Within is another way of saying error of the population mean. And the population standard deviation is known to be 28 pounds. Now, N equals Z alpha divided by 2 squared, no matter what N formula you use. This time we're not dealing with P and Q. This time we're dealing with the mean. When you deal with mean, you put sigma squared and then the error squared. Or square the whole thing. That's fine too. I don't remember which way your formula sheet had it. So okay, either way. Where do you want to start? All right. Well, if you want Z alpha, you need your alpha. Where does the alpha come from?
Your confidence.
90% confidence means alpha is 0.1. 10% or 0.1. To find Z, we do what? Divide by 2. Now, this is one that you might have memorized because this is a very common one. If you memorized it, that's fine too. I think it is. I don't remember. Nope. Wait, is that what you said? 1 point... No, you said a different one. Here's the area and our z-score. Okay. 1.645 is the z-score. Are we good? All right. So 1.645 times sigma, which is 28, okay? And error 3.7. And all that has to be squared to get your N. Alright, I might have the wrong decimals here because of my silly calculator, but close. How far off am I? So 9.6? I don't have a square button. Alright, so what do you do with that?
You round it up.
Always round in up. So 155. What else?
Can you tell me?
71? Yeah. You have to remind me though. I have a short memory. Okay. Formulate the indicated conclusion in non-technical terms. Be sure to address the original claim. Alright. Sometimes these questions can be a little funky, because they can state them in terms of the null hypothesis or they can state them in terms of the alternative hypothesis. So what I'm going to do is I'm going to look at the first paragraph and write down what I think it's supposed to be, and then see if that's an answer choice. If it's not, then I might have to adjust a little bit. So in our first statement, a researcher claims, oh, okay, there's a claim. I'm going to write that down. 62% of voters favor gun control. Assuming that a hypothesis test of the claim has been conducted and that the conclusion is failed to reject the null, state the conclusion in non-technical terms. Oh wait, this is a conclusion. Oh, this should be straightforward. Okay, hopefully. We'll see. When you fail to reject, does that mean you had sufficient or insufficient evidence?
Insufficient.
Very good. There is insufficient evidence. So immediately you should be able to go and cancel out some answers. Sufficient is gone. Sufficient is gone. All right. Not sufficient is the same as insufficient. Now, is your claim the null hypothesis? If you wrote this claim in symbols, how would you write it? P, because you're talking about a proportion.
Equals
0.62. Yeah. Now, would that be your null hypothesis, or do you need the opposite to be your null hypothesis?
would be simple.
Yeah, you're right. The null hypothesis would have been the actual claim. So, if your null hypothesis was the claim, there is insufficient evidence to do what? To warrant rejection of the claim. There you go. If you've forgotten that, there is a little flow chart in the book and on the PowerPoint to help you follow how to answer these. The words may not be exactly the same, but it's going to give you a pretty doggone close idea of how to match.
You're supposed to go back now?
Oh yeah, 68, is that what it was?
Yes, sir.
Alright, express the null and alternative hypotheses in symbolic form. Now, a skeptical paranormal researcher claims, alright, let's write down our claim. The proportion of Americans, I'm going to shorten this here, the proportion, that have seen a UFO is less than 3 in every 1,000. Can somebody write that in symbols? Yeah.
P is less than 0.003.
Tens, 100,000. Very good. So all he did was do the division. 3 in every 1,000, that's 3 over 1,000. And that's where he got the decimal from. Proportion should always be fractions that are less than 1. Now, I like to write the opposite of those symbols right now. So what is the opposite of P less than? Or equal to. Very good. Now we can write what? Hypotheses. Now for hypotheses, which one is always easiest to figure out?
Equal sign to 0.
Your null hypothesis is always the one with the equal sign. But what do you actually write? Just the equal sign. Why? That's another class. We are trying to simplify your life here. Just the equal sign. Which means your alternative is?
E is less than.
Less than. It's the other set of symbols. It's the actual symbols, not the opposite. Okay, so you write the claim in symbols, so you write the opposite of that. One is your alternative, one is your null. And the null is always the one with the equal sign, but just the equal sign. So you should automatically be able to cancel out the null hypotheses that aren't equals. So now you have a 50-50 shot. A lot better than 25% chance. Yes, sir.
Can you explain to me a little bit about the alternative?
The alternative?
Yes.
The alternative is the situation that you're trying to prove. The null hypothesis we can never ever prove. It's like in a court case, murder trial, it's most extreme. You always assume that they're innocent. So we're going to assume the null is true. That's kind of the status quo, what tradition says. And then the shocking would be if we actually proved the opposite.
Okay.
So if you have enough evidence to prove someone is guilty of murder, they go to jail. If we have enough evidence to show the alternative is true, then we could reject our assumption that the null was in fact true. Does that make that help?
Yes.
All right, almost done. What else? 72? All right, I'm going to do a couple more, and then I'm actually going to stop so I can stop recording and save it before anything major happens and I lose 2 hours of recording. Now that I said that, everything's going to shut down on me. Just watch. All right.
We could, if you want to, we guys have a little 5-minute break.
You're going to have to, so yeah. All right. What are we doing? Oh, same thing. All right, so we're trying to write the conclusion here. The manufacturer of a refrigeration system for beer kegs produces refrigerators that are supposed to maintain a true mean temperature of 49 degrees. That might be interesting, so I'm highlighting it. Which is ideal for a certain type of German, how do you say that word? Is it? Okay. The owner of the brewery does not agree with the refrigerator manufacturer and claims that he can prove that the true mean temperature is incorrect. So what is the claim here? Well, let's write that in words, exactly what the claim is, and then we're going to translate that in terms of math. So you might be right, but my brain doesn't work that fast. All right, so he claims this statement here. How do I want to write this?
That the mean is equal to 49 degrees Fahrenheit.
I think you're right. Hold on. So he's claiming the true mean temperature is incorrect. Well, they said the mean temperature was 49 degrees. So what is he saying?
So it's not equal to 49.
All right, so that's the claim in symbols. Are we okay with that? See, some of these, they don't put the claim into the actual claim statement, but they put enough information in their claim statement that you can go back and fill in the blanks. What's the opposite of that? All right. Now, what would your null hypothesis be? Mu equals 49, and your alternative? Now, what's important here that we're going to need to note to write our conclusion? Which one of these has the claim in it? Alternative, because that was the original set of symbols. It came straight from the claim. He's claiming that the mean is not 49 degrees. Now, we wrote all that down so that we can write our conclusion correctly. Now, what did they say we do? Reject the null hypothesis. So if we reject the null, is there sufficient or insufficient evidence? So there is sufficient evidence. Let's go and cancel out the ones that can't be. Not sufficient. Okay, so we have two possibilities left. There's sufficient evidence to do what? To what? Let's read and see what our options are. We can either support the claim or support the claim.
One's equal and one's different.
Yeah, you got to keep reading. One says different than 49%, the other one said equal to 49%. Well, what did we say? There's sufficient evidence to support our claim. What was our claim? The mean is different, because we said not equals to 49. Different from 49. So you got to be careful. Sometimes they turn it around on you a little bit. So A is the one that matches how we had it set up. So some of these multiple choice, it's better if you write down the steps as if you were doing a hypothesis test. That way you have everything there that you need. You don't have to go back and fill in gaps. If you follow the steps, you have less chance of making a mistake. All right, one more and then we'll take a break. 76. You know what? Can I just do all three of those in one shot? It's a lot better than one at a time. All right. So, Z, T, or neither. How do you determine?
That's what it's asking.
Nope. I want to know the definition. How do you determine Z, T, or neither? All right. Yes, I hear a lot of good ideas. What do both require?
Standard deviation, is it less greater than 30? Is it normal distribution?
Yeah, what do they both require? Z and T both require normal or n greater than 30. Okay, for Z or T. If you have one of those, you can do Z or T. What if you don't have normal or 30 or bigger than 30? If you don't have either one of those, what do you do? Nothing. You're done. That's another course. That's the harem. Never mind. I don't remember. All right. Now, if you have normal or n greater than 30, you can do Z or T. How do you decide which one?
Standard deviation provided?
If sigma, the population standard deviation, is known, who do you use?
Z.
If sigma is unknown, then use T. So let's go through these and make a decision. All right, so in 75.
Say that again, population standard. Is that what you said, population standard deviation?
Yeah, that's what these are.
Okay.
All right, so that's the rules. Now, in 75, do we have normal or n greater than 30? Yes. Which one? Normal. So, who do you use? I don't know. We have to check the next step.
We have standard deviation.
Standard deviation is known.
Specifically, sigma is known. So normal, you can look for sigma. Once you have sigma, you know that you need to use
Z.
Z. So immediately, cross out the ones that can't be. You now have a 50-50 shot. How do you figure out which one? What? How? All right, you get your alpha. Alpha comes from the 98%, so what do we get? 0.02. And we need alpha divided by 2. And which one of those is for 0.01 area? Is it? Not too far. 2.33 is correct. Are we okay with that? All right, what about the next one? Can we do Z or T? Why Z or T?
It's less than 30.
It's less than 30, so that doesn't do it for us. It's normal. Very good. And if it's normal, you can do Z or T. How do you determine which one? Sigma is unknown, so that tells you to use T. That was correct. Now, how do you find your T? Oh, first I can cross out Z's. 50-50 shot now. All right, how do you find your T value? This is different than the Z.
You do T alpha divided by 2.
So you need your alpha. 0.1. Alpha divided by 2 is 0.05. Now be careful. Alpha is for 2 tails worth of area. Alpha divided by 2 is 1 tail worth of area. That's important because on your T table, you have to know whether you're doing 1 tail or 2 tails. Let me bring it up. So at the top here, if you use your alpha divided by 2, that's 1 tail. If you do 2 tails, you have to use your whole alpha. It does not matter which one you do, as long as you understand whether you're doing 1 tail or 2 tails, because you get the same column. So alpha, I forgot what it was, 0.1. Our whole alpha is 0.1, our half of alpha is 0.05. It doesn't matter which one because you get the same column. To figure out which one, you need your degree of freedom. How do you find the degree of freedom?
1 minus
N minus 1. And they gave us N. What was it before?
10.
So 10 minus 1 is 9. And we go across until we're under our column, and there is your T. Remember, T values are in the middle. Z values are on the edges. It's backwards, so make sure you're very careful about that. So 1.833 is the answer. What about the last one? Why? Correct. It's not normal. And N is less than 30. So neither Z nor T works. Alright? Alright, take a break. I gotta save this before something catastrophic happens.